My name is Kyle Daigle. I am a platform engineer at GitHub. I work on API and webhooks. Who here has used the API directly, either for fun or for work? Okay, great. How many people say they integrate with someone that uses the API? Maybe a CI provider, an issue tracker? So, main goal right now is basically, I'm going to show you how we've used the API to integrate GitHub, the engineering organization, into GitHub, the product. And so most of the tips that I'm going to show you today are things that you can use at your own organizations to sort of level up your ability to integrate cross-product with different platforms, and then some tips on kind of how we've baked it into operational work and basically across the entire organization. So a lot of things that I'm about to show you are basically through pain that we felt in our own process. The APIs that we use are all public APIs. We don't have a secret API to do the things that we do every day to build GitHub. And almost all of these tools have a Hubot component, or chat ops. So Hubot, if you're not familiar, is an open source project that we run that allows you to use chat to, say, deploy, to check CI statuses, to search users, to run console commands, to check up on MySQL databases, so on and so forth. So I'm not going to cover that too much, but I wanted to point it out because it's a crucial part of how we use the API we develop at GitHub. And so if you haven't used that, or if you have a chat tool work, but you don't use a sort of bot to help you do things, definitely check Hubot out, because it'll definitely level up your ability to use the API to do GitHub-related things. So this is what I'm going to cover today. I'm going to very quickly show you how to get started on the API. We're going to automate some repository setup using organization webhooks, track and test output for using commit statuses, show you how to use deployments within the GitHub API, and then sort of tie that all together and show you how we use our API along with Nagios to help make sure that the engineering organization at GitHub is working really closely with the operational side of GitHub when things don't go exactly how we planned. And then I'm going to answer any questions that you have at the very end. So hopefully we can get through some stuff and I can answer your specific questions while we're all still here. So getting started with the API. Most of the documentation you'll need, both in API documents and sort of getting started documents, are at developer.github.com. So I'm going to show you some things that I might gloss over a little bit. If you have more questions about specifics, you can always go back here. The first thing to get started with the API is you need a token. A token is your way to work with our API to get the resources that you have access to. We do allow you to use basic auth, but we don't prefer it. And so I'm going to show you how to get a personal access token similar to an OAuth token if you were to work with a third party or within an application in your own organization. This is a quick and easy way to get a token to call the API and just get started when you're trying to figure out how you want to use our features. So this is within the settings page in your GitHub account. And within that, we're going to allow you to basically build a token and choose the scopes of your token, which is a whitelist level of permissions that you can say, yes, I would like you to have access to all of my repositories, or yes, I'd like you to be able to read my public keys. And so once you have this and you fill this little form out, you're going to get a token. And in my example, it's just ABC123. Running a simple curl command like this will give you the ability to see that the token works, right? This is the very first base set. It looks like a lot of people here have done something with our API or another API, so I'm not really going to belabor the point here. But if you haven't, it's very simple, and this is how you can get started. GitHub supports some client libraries. For the sake of my example, I'm going to be showing you Ruby-ish things. Sometimes I might cheat a little bit on the syntax just to make it more understandable if you're not familiar with Ruby. But GitHub supports a Ruby client, an Objective-C client, and a .NET client. The community has tons of other clients, though, so if your language of choice isn't showing up here, it's likely that there's an open source project that can get you where you need to go with using our API. All right, so that's the fast once-over on how to get started. Now we're going to start diving into how we use it. How we use the API internally and how you can use it. These things are sort of going to build on top of each other. This is like a art survey course, if you've ever taken one of those in college, where it's like, take this for granted, now I'm gonna show you some things. That's sort of what we're gonna do here. So organization webhooks. Well, the first question might be for a lot of people is, how do webhooks work, right? And so a webhook is basically a very simple action where in GitHub, something happens. I create a pull request, I comment on an issue, I close a pull request, I merge a branch. GitHub can send an event from us to your server containing a payload of information that you can use to build what you need on your side. And so in this example, it's very simple. It's just an HTTP post. It can look like a form post if you like. It can just look like a body of JSON. But once you get it on your side, you can use that information to call back to the API to update it, to call an internal system, to kick off a deployment. And this is one of the major parts of the API. It's our outbound API. It's how we're letting you know right away that things are happening, so that way you don't have to poll us, right? Contact us over and over again saying, hey, what's changed? Hey, what's changed? Hey, what's changed? The webhooks allow you to get that information as it happens. And so how do organizational webhooks work? So if we have a webhook that's sending events over, GitHub has a feature where you can install a webhook at the organization level. And so for most of us, an organization is our company. At larger companies, or if you use GitHub Enterprise, it might be your division or your area or your team. But what you can do is you can install one webhook for all the repositories that you have in your organization instead of doing it by repository. We still offer repository-based webhooks. You can set them up repo by repo. But this way, you can get a ton of different events that aren't necessarily available in a repo context. Like a new person joined the organization. Maybe you're onboarding a new teammate. You can get an event for that. So this is an example of what the payload looks like once you get it on your side. This is the JSON example. You can see they're pretty well hydrated. They're not very skinny payloads. Primarily, there's a lot of uses for, say, chat or messaging tools where you want to have all the information you need, just sort of reformat it and send it along. So there's a lot of information in here. It'll show you basically the action that was taken, the repository, some information about the repository, who took this action, what organization was this action a part of. It contains a ton of information. And so you can get it as JSON, or you can get it form encoded, so it'll look like a form post on your server side. To set this up, you can set it up within both the organization and within the repository. In the settings view of each of those, the form is super simple. It starts to look like this. Where's the URL? What content type would you like? Would you like us to use a secret so we can sign it and know that it's actually coming from us? And then the last step is choosing the events that you want. So you can get all of them. You can get just the push event anytime someone pushes code up to your Git repository, or you can get the variety of events here. And so the ones that I've chosen right now are the organization-specific ones, which anytime someone's added or removed to a team, and anytime a repository is created within a team. So I'll get into specifics about why those are valuable. But this is sort of the base setup for a webhook. You can also do this via the API. So if you're doing any sort of developer enablement or operations work and you don't want to go one by one in every single repository or organization, you can do all this setup via the API. So why do you care? The main thing that I think organization webhooks allow you to do is it allows you to stay in sync with team memberships in repository creations. So anyone, when you set up a new repository, does anyone have to spend a bunch of time getting it set up like the other repositories in your account? Does that ever happen? You have to set it up to point at a new chat room or anything like that? Yeah. And so what this can allow you to do now is you're going to have one organization webhook that's listening for every time a new repository happens. And then once that new repository comes in, you can receive a post at this webhook's URL. So this looks like Sinatra in Ruby, if anyone's familiar. Find a team ID, right? Maybe it's the engineering organization. Maybe it's a group of trusted admins. Maybe it's operations. Maybe it's a bunch of teams. And then use the API, so client.addTeam repository is part of those GitHub-supported libraries that I showed you. You can make a really simple call here, so now every single time you start a new repository, someone in your organization doesn't have to go through and go, all right, now we got to add the employees team, and then we have to add this team, and then we have to add the Slack webhook, and then we have to make sure it's talking to our CI, and so on and so forth. You can do this all just via a webhook. And so in some enterprise organizations, this could include letting a third-party compliance system know. It could include syncing memberships with another system. So if you want to use GitHub as your primary authentication mechanism, you could then go and say, all right, CI tool, make sure you let this person log in. Or, OK, internal system, this new person or this new repository was created. You should know about it right now. And so this webhook piece sort of ties into the next set of different tools that you can do, tasks that you can take with the API. The important thing to remember is just it's an outbound API. It has a ton of events, and so I invite you to go to developer.github.com to kind of see the different events that you might want to look at, because we cover a ton of them. And this is how a lot of our integrators keep in sync with our data, right? Instead of polling, rate limits are still a thing. And so you can't just spend the time polling. This is a great solution for that. All right, so we're covering webhooks. Now we're going to get into statuses and how GitHub sort of overloads them and uses them for some different things besides simple CI. So you might be asking, how do statuses work? So this is an example of Rails. This is just a PR that was someone made. I took a screenshot of. And at the very bottom of the page there, you'll see that there's the little green check mark that says all is well, and that the Travis CI build passed. And so that little piece right there is a status. If you've used continuous integration or any tools like Jenkins or CodeShip or Travis or Circle, any of those tools to build your code after every push, they're likely using statuses to do that. And so this is the simple use case, right? People using CI, any sort of automatic building? Raise your hands, raise your hands. OK, awesome. And so let's see what that actually looks like on our side. So this is still for you. You'd be hosting this in on one of your servers. Again, you're just going to get a post from a webhook, right? And that post will be probably a push event. Every time someone pushes up code, you probably want to make sure that that code is going to compile or run correctly. So the first step is pulling out the repository. The second step is pulling out the SHA, the unique identifier in your Git repository for that commit. And then you have your options. And the options are basically saying the context, what do I want to call this check, right? It might be CI, it might be a demo. You can give it a target URL so that you have the ability to say, when this builds, what does it look like? What do the logs say? And then a description. And this will be visible to the end user. Again, we call client, which is just using our internal library, and create this using SHA, and then saying it's pending. We're starting to do this build right now. We don't have a result yet. And so if you haven't seen these happening, I just took a couple quick screenshots. So this is a pending commit. A failed commit, pretty simple, right? And a passing commit. And this will all show up in the UI, both in the commit views in your PRs, as well as at the very bottom in the big box that has the merge button in it. And so now, how can we overload commit statuses, right? CI is why they were built, but there's a ton of other interesting use cases for it. So at GitHub, we have to run a bunch of different builds. We run the builds on the app. We run the builds at the enterprise version. We run the builds at the second enterprise version. And then we have something that we call GitHub Setup. And so I'm sure this has happened to almost everyone, but if you're an engineer, join a new company, and they're like, just pull the repo down and just get started. Run whatever the language-specific things that you need to do to get going. So rake db migrate if you're in Rails, whatever. And it all goes to hell, right? And it never works correctly, ever. And so what we did was we created a simple thing that on every push, we were going to bootstrap a whole new environment from beginning to end. And so what this allows us to know that every time we bring on a new engineer at GitHub, that again, I'm going to use Rails-specific examples because GitHub is primarily built in Rails and Ruby, the schema isn't out of date, and it's complaining that, oh, we don't know what we don't know what migration version you should be running. Or there's a gem dependency that isn't checked into the repo, but we just assume you have it because the person who committed it had it, and so let's just hope it all works out. And so you can see a pretty simple example at the top. We're just going to do what we did the last time. We're going to create a status with the pending status saying, OK, we're going to start this. At GitHub, we have a set of standard scripts that every repository has. And in this example, we'll say script bootstrap, meaning let's start from the very beginning. We're going to get the dependencies we need. We're going to install the gems we need, create the databases, and all of that. And then depending on the success of that, we can say, yep, it worked, or no, it didn't, or we have no frickin' clue what happened, error, right? And so for your projects, I would love for you to think, what would that script be? Because that's usually the first step. Maybe there is no script, right? Maybe it's just in a README, or maybe it's just, Godspeed, I hope you know how to get this going, right? And so the first step might be that script piece. But once you have that script piece, now you can use statuses to do for more than just CI. A lot of other open source projects will use statuses for contributor license agreements, CLA agreements. Has this person signed the CLA? Enterprise organizations or compliance-heavy organizations can use statuses to say, yep, all of these commits are correct. They use the correct message format. The contributor has an email address, all of that sort of thing. All of that can be used and shown in the commit statuses. And now we have statuses. Requests allow you to say this status must pass in order for me to merge this. And so you can decide what statuses, maybe it's all of them, maybe it's only a couple of them, but you can decide which of those you would need. So now we have statuses, we know the code is good to go out, so we can talk about deployments. And so how do deployments work? At GitHub, we show the deployments in the pull request. And so this is a really great way, if you use a GitHub-style flow where you're using pull requests primarily, to make sure that you always have a history of the actions that were taken on that code. And so you can say, yes, it was reviewed, yes, the CI passed, yes, Kyle pushed it to staging before he pushed it to production, right? Because if you do that, everything will be tracked in the PR. And so here it's just showing an example from Jake Boxer saying that he deployed it into production, and waited some time, and then he merged the PR back into master. So how do deployments work at GitHub? A lot of these features you won't see in the UI unless you use them. So things like statuses and deployments only show up if you have them. So basically how deployments work, you have to trigger a deployment event. And that usually happens via the API. Meaning, you could get a push, you could get action, a webhook, or this could be a chat command. This could be a button in your UI, where you make a simple API call to GitHub to say, I would like to create a deployment event. That event then goes back out via webhooks. So this could go to your servers. This could go to a third-party service like Heroku, AWS, Azure, where they receive this deployment event saying, I'm asking you to deploy this code. They'll start deploying it, and then report back success or failure with logs. So it starts with an API call. API call triggers a webhook. You receive it. You decide how to act. Generally, we talk in web parlance, but the very same thing could be done with native applications. Deployment might just be a build where you're going to create a binary and upload it somewhere. It could be an iOS distribution. There's a lot more options than just the web, which a lot of times people think this feature is primarily for that. So what does this look like? So to deploy and build your projects, it looks very similar in a way to doing statuses. So again, we're going to pull out the obvious stuff. We're going to pull out the repository. We're going to pull out the ref. We're going to say what deployment, what SHA or reference are we actually going to be deploying here. That could be a branch name. That could be an actual SHA. It could be a tag. And then we have a bunch of options. So the first option is task. This is something that you can provide to us. You don't have to say, I would like a deployment to happen using this command, right? You would use this on your side to say, OK, I'm going to take the task and run that command. That could be like deploy it just to staging. It could be deploy it with these command line arguments, anything like that. That's completely controllable and usable by you. there is the auto merge. And so auto merge says, when I request this deployment, make sure I'm up to date with my default branch. So generally speaking in Git land, that's master. If you have set up a different default branch in GitHub, develop branch, production branch, anything like that, we'll use that. Required contexts, and so if you remember back to the status demonstration, we said the velocity demo was the context that I was using. And so we can say only deploy this if these statuses have passed. Right, so you can kind of protect yourself just in case there's an engineer who missed the failing status, or you don't realize that something failed. This will protect you. It'll just come back and say no. You can give it a payload. Again, this is basically for you. So if you are in a native environment or you have to decide what platforms you actually want to deploy against, the payload would be a place where you can do a key value and say, this is what I would like. These are the settings that I need for this environment. The environment's pretty simple, right? Production, staging. If you use something like Heroku's review apps, which are really, really cool, and if you don't know anything about them, definitely talk to them about it. They can have different environments here, there for those. And then the description. The description is just the human-readable version of what we're talking about. Again, at the very bottom, you can see the create deployment call, again, using the client. This is basically the first step to getting a deployment out. And so at GitHub, we do all our deployments via chat. /deploy repo name, branch name to environment name. And then if there's a problem with that, the results will come back to the API, and it goes back into chat. At other organizations, that might be a web UI. It might be a button click if you're using the GitHub API to do this. But there's a bunch of different options around that. So once you ask for a deploy, the deploy actually has to happen, right? And a deployment can fail in a variety of interesting ways. And so, again, we're back to webhooks. And so you make the deployment, and then a webhook event goes out saying, all right, all you systems that are listening, this person would like a deployment of this ref. And so you can see that we pull out the repository again, the SHA, the deployment URL that we specified, and then we're going to say script deploy, right? And so originally, if you look, I mentioned saying, OK, you can set the task. You might just want to shell out and say, OK, do this task, or run this script with these options attached to it. But for this example, it's just script deploy. Depending on your situation, that might be a different call. And then, again, my Ruby-ish, if it succeeded, you can create a deployment status saying that it succeeded. If not, you can say that it failed. And so the benefit of this is that when you deploy something that doesn't work correctly, now your PR will say, Kyle deployed to production and it failed. And failed will be linked over to the logs that were generated from it. And if it succeeded, then even better. Then you just have a link to a reference of maybe where all the SHAs are at, maybe when all the dependencies are at, and you can track that completely. And so at GitHub, we have now the ability for us to deploy to production in stages, right? So that obviously we're not just going to put the code out and hope that it all just works. We can say, all right, let's just do a tiny, tiny subset. And you can see that in the PR, so that way when anyone comes back later, if there were problems or if things went OK, the PR is that complete record. And then yesterday, we released the integrations directory. And so there's a ton of partners. This is a very small subset of who exists, but is currently in the directory, and we'll be adding more. And so like I said, a lot of people use AWS Code Deploy. Heroku has their new pipelines feature. They also have their review apps. That way every single PR can have an immediate app without having to do any work. It's a very cool feature if Heroku is an option for you. And then a lot of the CI providers will also do deployments for you. And so all of these are at some point reporting back to GitHub in the UI as well. So you get that benefit of having it all in the PR, but you're not going to have to set it up all on your own. So you don't have to feel like this is something that you need to go out and build on your own. It's possible or probable that one of the tools or systems that you use can already provide this for you. OK. So the last piece I'm going to show you before we hopefully answer some of your questions is sort of a mishmash of everything I just showed you in one place. Anyone work in operations or sysadmins or anything that Yeah? Okay, awesome. And so this was built by an excellent engineer slash sysadmin at GitHub. We're trying to solve a problem where alerts would happen and we'd get those notifications, but there wasn't an easy way to collaborate on those alerts across teams, across functions, so across engineering and operations, across engineering and systems. And so excuse some of the redacted information, but what this allows us to do is we have an internal tool called Haystack, which is similar to any sort of error tracking tool, like Honey Badger, if you've used that, or Break, where when errors happen at a central location, and what we do is we track their velocity. And when the velocity gets too high, just too many errors per minute, someone from the engineering organization who's on call will get paged, and not just operations. So the important thing in this example is at the very bottom, and so sorry it's kind of low, it says cc at GitHub/GitHub haystack on call. And so that is a team at GitHub. And so your organization can have a multitude of teams. And some companies only do a few for engineering and operations and marketing, let's say. At GitHub, there's a lot of specialty teams. So there's GitHub/platform, GitHub/hooks to deal with webhooks related things. And so when these things come in, now we're immediately mentioning those teams. This doesn't replace something like PagerDuty or an actual phone call that says, wake up, the thing's broken. But what this allows us to do is in the morning, if let's say we weren't on call, we're all able to see what happened and answer and say, okay, yes, I know why that happened, this is what happened, et cetera. And so that initial set was just a simple issue creation via the API. Now what we do is we actually comment on that same issue using Graphite. So we're using the GitHub API to generate an issue comment. It's a link to a bunch of Graphite graphs. And those Graphite graphs are a snapshot in time. We know when this alert happened, this is what the time before and up until now looked like. And so it can load in a bunch of different other information. So we can load in playbook links. So if we had written documentation in another GitHub repository, that information can be pulled in as well. So it can say, okay, this is what the engineer who built this system said you should do when everything went to hell, right? And that, again, can use the API. And then other diagnosing can happen in chat. Again, GitHub's a huge chat user, and so we can use mentions from chat back into these issue comments to sort of track what happened. And so this is the awesome, gnarly command that gets run when something happens in Nagios that needs to be reported. And so it basically sets a variety of environment variables. And then you call, in the middle there, gh9zap update alert, where we're actually posting to this little application that we run that does these API calls for us with the information. And I'm going to post my slides after the talk, so don't feel like you have to decipher this from your iPhone. And so this is what the app looks like. We're obviously very simplified. But basically it's saying, OK, we're going to get this post from Nagios. The app takes it with the alert parameters that were sent in, the environment, the error that happened, how many times the check failed, and all of that, and then do a simple response with a 201. So it's basically just going to say, OK, yep, got it. And then now we start talk to the API. So now that we have the alert in a background queue, so that way we're not holding that web event open, Nines goes and says, OK, let's create an issue for this alert that got triggered. And that issue will use a template holding the main information. OK, we want to CC the person's team. We want to CC the playbook that happened. We want to CC or paste in the information that's specific from that alert. And then that whole piece is ultimately what generates. And so once we have this information again, we're able to essentially go through and have a one-stop shop to talk about the actual check that failed. We close the issue once the check passes, so it's not just sort of lingering open. You may choose for your organization not to do that, but that all happens back through the same flow that I just showed you. And then we're able to basically look at these in a weekly context and say, OK, why did this check pass? Why did this check fail? How did engineering respond? How did ops respond? And so the cool thing about this is it's just all automatic. Even that weekly update just uses the API to do the work that we need. So I went through 3 examples plus explaining webhooks on basically how GitHub operates using the API. We have some really great documentation at developer.github.com, which covers both the events, the API endpoints that we have, as well as guides. So if you are new to this or you're not entirely sure how to use this, we have guides that cover the basic use cases, how to get authentication. If you're interested in building an integration against GitHub for fun and profit and not just for work reasons, we can cover basically how you would want to authenticate and actually build an OAuth application instead of just using a personal access token. All of that is probably better covered there than in a talk, and so I definitely invite you to take a look at that. We have a fair amount of time left for questions and answers about the API, the platform, how it works, anything like that. And so I'm happy to answer your questions now. And I think we're just going to do it where you can speak very loudly, and I'll repeat it for the live stream. So awesome. If you have any questions or you'd like to follow me on Twitter or GitHub, I'm at @Daigle. Thank you very much, everybody. All right, so questions. Yep. Sure. So the question was basically, can you describe a bit more about the deployments API and how it's specifically used at GitHub when we deploy? So at GitHub, like I said, we use chat primarily, and so for me as an engineer, I'll go into chat and I'll type /deploy GitHub the repository /branch to staging. What happens there is that first step in the deployments piece. Let me just back up through it. And so Hubot will then make a HTTP request to the API saying, start a deployment, this branch, this environment, Kyle asked for that. And so once that happens at GitHub, we're going to take a webhook, like I said, except it's going to go basically back to us. Not GitHub, the public API, GitHub, the how does GitHub deploy its code. And so you might have to build that for your particular environment, basically saying receive this, run the deployment, whatever that looks like for you, and then report back. For a lot of you, this might just be Heroku or Azure or Code Deploy or any of the other sort of tools that already have this stuff baked in. But the only custom piece really besides that initial API request, the create a deployment event, is the service square. It's saying, OK, receive this, and actually do the deployment, which is too specific to everyone's own deployment environments. But yeah, all that Hubot is doing behind the scenes is basically starting the set of dominoes, saying, OK, create the deployment event. Yeah. Yep. Where would people find that if they were looking? OK, great. So what was your name? Chris? OK, so Chris just mentioned that he just recently wrote a book for O'Reilly, building tools with GitHub. So awesome. So it's about building testable API applications built on top of GitHub. So it just went into early access. So it sounds like if you go to O'Reilly and you search for that book, you should be able to get it. Awesome. Thanks, Chris. Yeah. So it'll depend on the ref that you've chosen. Oh, I'm sorry. So the question was, if you have 3 PRs that you've already merged to master, and then you go and are doing a deploy, will they each have the deployment event marked in it? And so I believe it's going to matter quite a bit about what ref you're choosing. So assuming you're deploying master, I don't believe that each PR will have it in there because this is primarily built for the flow of deploying the individual branches and then merging it back to master. I know that forget the company's name, so I don't want to be wrong, but what they do is they essentially do something very similar to this. They either open their PR that can track, like, this is the history of code that's going out, or create an issue for that deployment. If you're doing, say, daily deploys or weekly deploys or something that's not per PR basis, there's a couple different ways that you can either use the API to create issues to do that, or have one PR that will encapsulate the changes that are going out to production. But it will depend on what ref you're choosing back a step, but in this piece here at the top, the ref that you're starting out with. Yeah. Oh, yeah. Mhm. And so, yeah, so he was very kind to ask me this last night, and I couldn't remember the answer, and so I said, all right, I'm gonna go make sure I know this answer so I don't look like an ass in front of everyone. So luckily, thank you for cheating. The question was, if you're using a forking workflow, like is mainly done in open source, but organizations prefer that their engineers fork the repository so that way the main repository stays completely clean. And then if you issue a PR over here back to the main repository, how do you keep this repository tested? How do you keep the tests updated as this PR in this separate branch works? And so the event that I forgot about was the event is the pull request event with an action of synchronize. And the synchronize action is the piece that's saying, okay, this was updated, the git SHAs were changed, and so it'll send you an event that says action synchronize with the new SHA, and so that you'll be able to use to actually say, okay, I need to run this again for this other PR or for this other repository that's not in my complete control. And so we discussed last night about how if you use Travis for open source work, they will build PRs if you let them for outside repositories for forks, and that's the event in action that they use to do that. Yeah, no problem. Awesome. Any other questions? Yep. So the question was, what about branch protections? And so the API will still respect if you set up a branch that's been protected or or via required statuses, and you're trying to take an action where either one of those won't be allowed, the API will return 422, I believe, with the response saying this branch can't be deployed or can't be merged, or the data can't be changed in it because this is a protected branch or this is a protected status. Oh, no. Because I want to protect a branch by the API, not currently. Yeah, that has to be done in the UI at the moment. Yeah. It makes a lot of sense. Yeah. Mm-hmm. Yep, there's nothing. So the question was basically, if you're protecting or requiring a status, or you have a protected branch and you want to make sure that your tool that isn't a fully built or baked integration to GitHub, can you still use all those things? And so the answer is essentially yes. Once you set those parameters and requirements on the GitHub side, the entire system has to listen to them. It's not so much that a third-party tool is respecting those changes. We're enforcing the side. And so if you're using an open source Jenkins or something like that to do the work, it'll have no choice but to respect the rules that are in place on the GitHub side. They may not respond clearly as to why something failed if they're trying to take an action and we're returning an error, and maybe they aren't giving you that error in return because it's a newer feature at GitHub. But yes, it'll all still continue to be protected. Yeah.
To what extent
Sure. So the question was, to what extent is the GitHub web view a client to the GitHub API? Essentially none. The web view is almost entirely the Rails application using, you know, and sort of just normal work. We do use PJAX to up per click, so it's not actually reloading the entire view, it's reloading a subset of the view. But we don't use the API to render the UI at all, to my knowledge, but definitely not in any major way. That's all completely separate. So the APIs are primarily for either, they either came from our own interest in building them because we needed them internally, or our customers or integrators, but they're definitely focused primarily for the automation side and not for rendering our UIs. Yeah. I think probably only one more question if there is one. Okay, awesome. So if you have any more questions, I really invite you to also, you can just go to github.com/contact or email support@github.com. They're a really awesome group that is very technical, and ultimately, usually it comes back to the engineers anyway. So if you have any more questions, check that out. But otherwise, thank you very much.